Hi everyone, I'm Adam. In this problem, for the form of the conic that we have, in our polar equation, r equal to 2e divided by 1 plus e times cosine theta, for each of the values of e equal to 1, e equal to 0.5, and e equal to 1.5, we're going to identify the type of conic that we get, and then we're going to use a graphing utility to make a graph of that. So to start with, based on the values of e that we have, we can identify what type of conic we would get. Well, first we'll go ahead and list this out. If we look at the form of the polar equation that we have, and think of, just make it slightly more general, if we have r is equal to e times p divided by 1 plus e times cosine theta. So from this form, if e is between 0 and 1, then we know we get an ellipse. If e is equal to 1, then we know we get a parabola. And if e, say, is greater than 1, we get a hyperbola. Okay, so without even writing anything else down, we can identify what we have. But since we're going to plug these into our calculator in a moment, we'll go ahead and write down what we have. So for part A, all right, so we have e is equal to 1. So our equation is going to be r equals, well, 2 times 1 divided by 1 plus 1 times cosine theta. And B, see, we'll have r is equal to, say, 2 times 0.5, where e here is 0.5, divided by 1 plus 0.5 times cosine theta. And lastly, C, where we have e is 1.5. R is equal to 2 times 1.5 divided by 1 plus 1.5 times cosine theta. And lastly, like we said, what do we have? So coming over here for A, where e is equal to 1, when we graph this, we should see the graph of a parabola. And for B, where e is equal to 0.5, that's less than 1, we should see the graph of an ellipse. And lastly, e equal to 1.5, greater than 1, we should see the graph of a hyperbola. All right, so let's take a look at this in our graphing utility. Okay, so first thing to do, we'll go into our mode and make sure we're in polar mode. And we'll go ahead and sketch this one at a time, starting with A. So we'll go ahead and first type in our equation. So for R1, we'll take R is equal to the numerator 2 divided by 1 plus cosine theta, all in parentheses. So 2 divided by quantity 1 plus cosine theta. And for our window, we'll go ahead and take theta min to be 0, our theta max to be 2 pi, and our theta step something small, something like 0.1. And let's say for x min, we'll take negative 10 and x max positive 3, and our x scale to be 1. And y min we'll have as negative 7 to y max of, say, positive 7, and our y scale to be 1. And go ahead and press graph. So we're going to see it sketched out in 2 parts. With there, it looks like we have the graph of a parabola opening up to the left, but that's what we have. Okay, now for part B, But we're going to go back in and say erase the equation we just did. And now for R1, we're going to type in 2 times 0.5, or 1, divided by quantity 1 plus 0.5 cosine theta. And for our window, let's still leave theta from 0. So theta min 0, theta max to 2 pi. Our theta step is 0.1. But let's take our x min from -3 to an x max of 3 and an x scale of 1. And let's take our y min from -3 to a y max of +3 and y scale of 1. And press graph. So looking at this, we should see the graph of an ellipse. And after it's done sketching, that's what we get. Now lastly, we do part C. So going back into our equation input, so clear out the equation we just had. And for R1, we're going to type in 2 times 1.5, or 3, divided by quantity 1 plus 1.5 times cosine of theta. And for our window, again, we'll leave theta min at 0, theta max at 2 pi, and our theta step at 0.1. And for x min, we'll go from -3 to x max of +10 and x scale of 1. And our y min we'll take from, say, -10 to y max of +10 and a y scale of 1. And press graph. So here in pieces, we should see our hyperbola being graphed out. So in the end, we should see our hyperbola opening up to the left and right, even with the asymptotes plotted in between. So there we are. Thank you very much.